All right, so today's lesson is going to be on Le Chatelier's principle. And Le Chatelier's principle states that when stress is applied to a system while that system is at equilibrium, my reaction is going to shift in the direction needed to relieve that stress. All right, so what we're talking about here is in terms of balance. We want to think about balance. All right, so if I stress the system, what is going to happen for the system to return to where it was? So let's look at it in terms of concentration. If I was to increase concentration, I'm going to shift toward the opposite side in order to use up what was added. And if I decrease concentration, I'm going to shift to the same side in order to replace what was moved. So if we wanted to go back to the same equation where we had nitrogen, we had a hydrogen, and we had ammonia gas, and we've looked at this. All right, so what does that mean? If I add hydrogen gas, I need to use up what's been added. To use it up, I need to make products. Shift right. If I take away hydrogen gas, okay, so I'm going to remove hydrogen gas, well, I need to replace it. How am I going to replace it? It's a reactant, so I have to make more reactants. Shift left. All right, temperature. An endothermic reaction and an exothermic. So an endothermic reaction, we add heat. If we add heat, we shift right. If we remove heat, we shift left. And in an exothermic, if we add heat, we shift left. And if we remove heat, we shift right. So what does that mean? Let's look at our equation. If this was an endothermic reaction, heat would be a reactant. If this was an exothermic reaction, heat would be a product, okay? So we can either have heat as a product or as a reactant. So let's just say, what about if it was an endothermic reaction, okay? If I add heat, I add reactant. If I add reactant, I need to get rid of what I've added, shift right. If I take heat away, then I'm removing a reactant. So I need to replace that reactant. I'm going to shift left towards the reactant side to produce reactants. If this was a exothermic process, then we would have heat as a product. So if I add product, I have to get rid of it. Shift left, make reactants to use up the product I added. If I remove heat, well, then I have to replace it. So I'm going to shift back to the right to replace the heat that was added or that was removed. So now you will always be told whether heat is a reactant or a product. You will be given that information. Pressure. Another way to think about pressure is through volume. We know that pressure and volume are inversely related. So if I decrease volume, that means I increase pressure. If I increase pressure, I have more collisions. So I'm going to shift toward the side with the less number of moles. All right, so think about it in terms of logic. How do I get back to where I was? If I have more collisions, I need less. So how am I going to get less collisions? The side with less gas. If I increase volume, then that means pressure's decreased. So I'm going to shift toward the side with the most number of moles, because if I decrease pressure, I have less collisions. Less collisions, I need to get more. So how am I going to get more? By going to the side with the more moles of gas. All right, so in this example up here, let's say I was to decrease volume. If I decrease volume, that means I have increased pressure. I have more collisions. I need less collisions. My reactants have 3 + 1, 4 moles of gas. My products have 2 moles of gas. So if I increase pressure, more collisions. I want less collisions. The product side has less gas moles, so I would shift right. All right, if we were to add a catalyst, when we add a catalyst has no effect on the equilibrium constant. Now, I told you just a minute ago that I would give you heat as if it was an endo or exothermic. So when you look at this equation provided, you'll see plus 22 kilojoules. Heat is measured in joules or kilojoules. Typically, in terms of a reaction, we measure it in kilojoules. All right, so I have 22 kilojoules. That is the heat. So in this reaction, we would say this reaction is an exothermic process. Heat is being released. So let's do some practice examples with Le Chatelier's principle. All right. If I add NO2, I'm increasing my reactants, which means I need to get rid of them. So how am I going to get rid of them? By shifting right and making more products to use up the reactants I've added. If I remove NO2, all right, I take it out. I need to replace it. So I need to replace those reactants, which means I am going to shift left in order to make more reactant to replace what I took out. If I remove heat, heat is my kilojoules. Heat is a product. I need to replace what I have taken out. So to replace it, I need to make more products. I have to make more heat. So that would be a shift right. If I decrease volume, all right, a decrease in volume means an increase in pressure. An increase in pressure, more collisions. If I have more collisions, I want to get back to where I was. I need less collisions. Need less. So I'm going to shift towards the side with the fewer moles of gas. I have 2 moles of gas as our reactant. And on the product side, I have 2 plus 1, so 3 moles of gas. So we'll notice here, if I need less, I'm going to shift to the left where I have fewer particles of gas. Shift left.